So for this video, we're going to talk about work. Work is used in everyday language to mean the total amount of effort required to perform a task. Now, I'm pretty sure if you take physics, you understand work. In general, if an object moves along a straight line with a position function, then the force of an object is given by that equation. This is Newton's second law right here. Newton's second law of motion. So you have m is the mass, and a is the acceleration. So the work here is force times the distance. Be careful with the unit. So I put the unit here for you. So if the force is newtons, d is in meters, then the work is gonna be in newtons times meters, which is joule. So, but if the force is in pounds and d's in feet, then we have foot pounds, okay? And foot pounds is 1.36 joules approximation. Anyway, let's try number 1 here for part A. The work done in lifting a 1.2 kilogram book off the floor to put it on the desk, that is 0.7 meter high. So first thing we need to do is we need to take care of the force, right? So the force is m times g. G is gravity. So what we have right here, the mass, 1.2. And gravity is given right there. Gravity is 9.8. So that's going to be 11.76 Newton. Okay, so that's the force exerted by the mass and the gravity. Then we're looking for the work. So work is going to be the force times d. So in this case, the force is 11.76 Newton times d, which is 0.7 meters. So is about 8.2 joules. Okay. Now, what we have in part B, you see right here, we have 20, how much work is done in lifting a 20 pounds weight 6 feet off the ground. So in this case, we don't have to multiply by the gravity because we are given in weight, not mass. So what I have, I can just use the formula right away, which is 20 pounds times 6 feet, which is 120 foot-pounds. Okay. Now, we are doing this as long as the force is constant. So what happens if the force is variables? So it's going to change, right? Therefore, we have the definition for work. Now, the work done in moving the object from A to B is going to be the limit of that quantity that you see right here. So if you're taking the limit, you're going to get the work done in moving from A to B. And that's just the integral from A to B f of x dx. Okay, so you see right here in example 2, we have a particle is located a distance x feet. So we don't know we don't know, so we call x as the variable. A force of x squared plus 2x, so that's f of x pounds x on it. How much work is done in moving it from 1 to 3? So using equation 4 right there, I can just plug it in from 1 to 3. And then I have x squared plus 2x dx. Then we take the antiderivative. From 1 to 3. Then we just plug it in, right? Three squared minus 1/3 plus 1. So when you evaluate, you're going to get 50 over 3. So that's going to be 50 over 3. That's going to be in foot-pounds. Okay, because you see right here, we have pounds. And right here, we have feet.